Alright, in this problem we're going to explicitly use the definitions of 1 and 1 and onto to show that this function, f of x equals 5x plus 2, is a bijection, and then we will find the inverse function. Parenthetically, we know that if I draw the graph of this function, it's going to look like this, y-intercept of 2 and a slope of 5. This clearly satisfies the horizontal line test, and so this function will have an inverse. Now that's a pre-calculus way of doing things. We're going to do things more explicitly using the definitions of 1 and 1 and onto. So, to show that f is 1 to 1, suppose that f of x1 is equal to f of x2. I want to show that x1 is equal to x2. So 5x1 plus 2 is equal to 5x2 plus 2. Well, I've got 2 on both sides, so I can subtract 2. And then I can divide by 5 on both sides. And so if f of x1 is equal to x2, then x1 is equal to x2. So f of x1 equals f of x2 implies that x1 is equal to x2, so that the function f is 1 to 1. So to show that f is onto, let y be some real number, and I choose a real number because that's the range, or the codomain here, given that the codomain is all real numbers. Okay, where we must find a number x, so in the domain, so that f of x equals y. Well, that's a straightforward algebra problem. F of x equals y, and so 5x plus 2 equals y. So 5x is equal to y minus 2, or x is equal to 1/5 times y minus 2. So there's my number. If y is equal to some real number, then there is some number in the domain so that f of x is equal to y. So f is a bijection, and the inverse we've actually basically did when we established that it was onto is 1/5 times x minus 2. And so that is the inverse function. And the domain of f inverse is the range of the original function, which is the real numbers. The range of f inverse is the domain of the original function, which is also the real numbers. So that is establishes that f is a 1-to-1 correspondence, that it's a bijection.